Hello again. So before I go into evaluating my second course tool, I did want to just talk quick about my first tool again, my class website. I did a quick Google search and I found that Google has just a little list of different ways to make your Google site more accessible. Now, I had no idea that they had this on here. Now, a lot of this information was suggested in the textbook and in the guidelines, like putting things in different font sizes and colors, and highlighting, adding alternative text for an image, and things like that. I had no idea that Google even had something set up like this, so I just wanted to share that real quick. And all I did was Google how to make your Google site more accessible, and this is what came up. So now I'm going to go into my second tool. I use math journals in both of my classes. It helps keep everything organized. It really shows the connection between different topics. And it's fun to be a little interactive. We glue a bunch of stuff into these journals and the students really enjoy it. So one of the things we had in the journals towards the beginning of the year, or I should say around halfway through the year, you can see this is from November, when I taught slope, we glued in this little slope puzzle. So I am evaluating, I guess, sort of both the image of this, because if you recall from part 1 of my video, I do post images of all of our class notes on my website, and I guess just the activity itself, how we did it in class. So it's a little bit of both, the digital file, the JPEG, and the physical paper that we used. So again, I'm going to go through each principle, and I'm going to go through each little sub-principle and just talk about the notes that I made for each. So I'm going to start off with engagement and recruiting interest. The students chose what they wanted to start with. Now we did, when we glued these in, we glued them in positive, negative, no slope, or zero slope, and undefined. But they decided if they wanted to start out with all of the graphs and sort them, okay, this is positive because it's going up, this is negative because it's going down. I let them decide if they wanted to do that, or if they wanted to say, okay, let's find all of the positive examples of slope first and set them aside. So they kind of decided how they wanted to do it, and I went with it. As you can see, I do have various representations of slope. So if we're just looking at the positive one here, you know, you can see it in standard form. We took it out of this form and we translated it into slope-intercept form. That's what they were more familiar with at the time. There's also an input-output table, as we called them in class. There are 2 points here. You would have to calculate the slope, and there's a picture of a graph. So different representations there. The only distraction, there would be no distraction if this was just the image online. And maybe if someone was absent or they glued something in the wrong spot, they wanted to see the right way to put it in. There's not really a distraction there. The distraction in class, though, all the cutting and gluing. The cutting, some of my students are just so meticulous, and the cutting could really be a distraction for them. So I would make that easier for them by having it already cut out. Now, I did not do that for my students because none of them have anything in any of their IEPs or GIPs that required that, and honestly, I had 30 students and there were so many of these, and I just was not going to cut them out for them. But if it was 1 or 2 students, I definitely would. Next, we'll move on to the next part of engagement: sustaining effort and persistence. I did not do the heightened salience of goals and objectives, just did not do that in this activity. As for varied demands and resources to optimize challenge, there was no alternative to this. We did this in class. We started off as a whole class. I was leading the discussion and the activity, and then we moved to a more student-led, and they were saying, okay, I think this one is no slope because it's y equals 7. There's no m times an x. If m was 0, that's why it's not there. So they were kind of leading that. But there was no alternatives. They couldn't, you know, do a worksheet instead of doing this in class. As for the collaboration and community aspect, I kind of did touch on that already. We did this as a class, starting off with me leading it, asking some questions, and then they were able to ask and answer those questions themselves without much help from me, which was awesome. And increased mastery oriented feedback. I did give them immediate feedback, but it was more of just yes, this is right, or no, this is wrong, and here's why. So that was mostly for these two down here, the no slope / zero slope and the undefined. They kept getting those mixed up. So mainly I was just saying, this is no slope. It's not, as x increases, y is not doing anything. There's nothing happening. Whereas this one, x is not doing anything at all, but y is increasing. That's why it's undefined. So that was more of the feedback that I gave them. Self-regulation, I did not do anything with this. My students were fine with it. No one got too upset. No one freaked out that it was too difficult. So behaviorally, they were just fine. I did not do anything there. Now, moving on to representation. Perception, I didn't really customize the display of anything. I mean, I do have the various displays of slope, again, with the table, the points, the graphs, and the equation. But other than that, nothing's really customized. I suppose if I had a student who was visually impaired, I could have printed this out larger for the student. Would have made it easier for them to see. As for language and symbols, I taught them the definitions of positive, negative, no slope or zero slope, and undefined slope, and examples of each in previous classes. I had also taught them how to solve for y and how that slope-intercept form. I taught them how to find slope from a table, and I also taught them how to use 2 points to find the slope of a line and find the slope from a graph, obviously. For clarifying syntax and structure, we made connections between the different displays of slope. The easiest one to see the connection between would be the table and the graph. The graph, you can see it's going up. The table, you can see as one goes up, the other also goes up. Likewise, if we're going backwards, as one goes down, the other goes down. I did not do any decoding with my students, really. They really seemed to get it. We had spent a couple days going over the basics of slope before we did this activity. Promoting understanding across languages. I didn't have any ESL students, so I did not do anything specific there. And illustrate through multiple media. Again, just the different representations of slope that we have here. As for comprehension, that last part of representation, I'd already taught the prerequisite knowledge that I just mentioned, the different types of slope, solving for y to get it in slope-intercept form, identifying which part really was the slope in that equation, and so on and so forth. Highlighting patterns and critical features, big ideas, and relationships. We did multiple examples of this. We didn't just do this one thing, we're done. We did it, you could see 4 times, 4 different things, and within that, 4 different representations. For guiding information processing and visualization, this was interactive, and it was also chunked. So I did not just give them this big list of 16 different displays of slope and say, figure it out. We picked up one, we cut out all the puzzle pieces, picked up one at a time, and said, okay, this graph right here, this is a positive slope because it's going up. Whereas this graph right here, it's nice and flat, nothing is happening, it's horizontal, that would be no slope or zero slope. So we went just step by step, and that really made it easier, less daunting for the students, I should say. As for maximize transfer and generalization, we did make some generalizations about equations with no slope and equations that had an undefined slope. So we came to the conclusion that anytime it was y equals just a number, that was no slope, and x equals -8, that was just undefined. But you can't see that in this image. You can't even see it if I were to show you my math journal that I use to kind of guide the students of what they should put in their math journal. This was just a discussion that we had in class. So this paper copy itself does not support that transfer and generalization, but the discussion we had in class did. As for the last part about action and expression, vary the physical action, vary the methods for response and navigation. There were no alternatives to this assignment. I believe I already mentioned that. Everyone had to cut this out, everyone had to glue it in. And optimizing access tools to and assistive technologies, this was not done because, again, it was just paper. The next part, expression and communication. Use multiple media for communication. It's a bit of a stretch, but I would just say the different types of slope that are displayed here. Now I did not have any alt text for this. If this would have, when I posted this image on my website, I did not explain what it was, and I should have done that. Perhaps I would have focused more on doing that if I had a student who was visually impaired or needed that modification. The next little bullet here, using multiple tools for construction and composition. I did let my students use a calculator, and they were allowed to write on this. We used the formula right here, as you can see, the slope formula, y2 minus y1 over x2 minus x1. Filled that in there. The last bullet of this section, build fluencies with graduated levels of support for practice and performance. I scaffolded this activity when I taught it. So we started off, I said before, as a whole class, then we moved to, it really just flowed into the students being able to do it themselves. We still did it all together, though, to make sure that everyone was gluing the correct pieces into the correct spot, and there was no gluing down the wrong part and then ripping it out, getting frustrated. None of that happened. But again, you can't see the discussion that we had by just looking at this, and you couldn't see it by just flipping through their math journals. Finally, the last part of this principle is executive functions. Again, I scaffolded this lesson. I did ask my students to stop and think, and then I asked them to explain mostly for these two different types of slope down here, the no slope, /0 slope, and the undefined. They kept getting these mixed up, and it was brand new content for them, so I understood, and after a while they did start to understand it, and they made those connections between, you know, if it's no slope and you have points, they all have the same y value, and if it's undefined and slope, then all the points have the same x value, so they did make those connections there. This is basically a graphic organizer. It has positive, negative, no slope, undefined, and then 4 examples of each one. So it's a more fun looking graphic organizer in my opinion, because it is a little puzzle. There was no self-assessment in this activity per se, but again, I do have a little self-assessment that I have my students do at the end of each of my lessons, but there was nothing physically that they wrote on this or that I had an image of on my website for them to self-assess. Overall, I think that my website could be a little more accessible, and again, I plan on delving into these suggestions a little bit more, especially the including alternative text. I think that the paper, it was not really made according to the UDL guidelines, and I hope to kind of change this activity a little bit next year and kind of align it a little bit more to them. And I am looking forward to trying that out. So thank you so much for watching my videos.